hey, I'm still on vacation. You're not. You're watching this at home. So I shot this on my trip to the Bahamas, and because I was wondering who knows more about solutions, whether they're saturated, super saturated, or unsaturated, than the people who live in it. The fish. Look over there. There's a fish. There's a fish. There is a fish. So I'm here trying to figure it out. So hopefully you'll learn something from this podcast. And yes, I am swimming underwater with a hat on. And yeah, I probably could use a shave. Basically, it's about saturated, unsaturated, and supersaturated solutions. You need to realize that solutions can be a solid dissolved into some liquid solvent, or it can be a gas dissolved in some liquid solvent, or it can be a gas dissolved into another gas. So just as long as you understand that, then we'll talk about the three different types. First one, unsaturated. Well, what does that mean? It will hold more solute. So that first test tube, this thing could use some more salt or sugar or whatever you're putting into it. More will dissolve into it. What does saturated means? It means that all the solute that can dissolve at a given temperature has dissolved. In other words, if you tried to add any more solute to it, could be a gas, could be a solid, if you try to add any more to it, it just will not dissolve. Those crystals sit down at the bottom, not doing anything. It just won't dissolve. The last thing is supersaturated solutions. That's when more is dissolved than is possible. More is dissolved than is possible. What does this mean? This means that you got the solution really, really hot. You made the solution saturated, so you added a lot of solid to it. Or in the case of a gas, you got the solution really, really cold and you added a lot of gas. And then you filtered it to get out any remaining solid, and then you let temperature go back to normal. So if you're doing a solid, you heat up the water, you dissolve as much solid as you can, and you know that because there's some solid left on the bottom. You filter it out, and then when you filtered it out, you let that solution sit and go back to room temperature, and that would be a super saturated solution. And when you add crystals to it, more crystals grow from it. So it's just waiting on some kind of shock, some kind of addition or something, or change in situation for those crystals to grow. And I've got a movie to show you all this. So what you see here is a supersaturated solution. You can't tell that it's supersaturated because it's just sitting there. It could just be water, right? So let's see what happens when we roll this forward. We're going to add one tiny little crystal of something. Going to drop it in there. There it goes. And as you notice, that crystallization spreads. That first crystal is a seed crystal, and the other ones are forming based on that. So there's a lot of solid forming throughout this whole thing. Sometimes you call this frozen ice. If you want to see more videos of it, look up supersaturated solutions or hot ice maybe on YouTube and you'll see it. So let's see another one. Again, sodium acetate is a chemical that has a really high solubility, and so a lot of people like to play with it. So what happened? I'll leave you to figure out. We'll talk about it in class, but try to think what would cause that to happen. See, she made a supersaturated solution of sodium acetate. Sodium acetate crystallized and she popped it out. If you notice then, as she pours it out onto a couple crystals of sodium acetate, it's forming awesomeness because it's crystallizing based on the fact that there are other crystals there. This very same thing happens in Yellowstone. As the water comes out of the ground and it's really hot, as it cools down, it's saturated, and so particles come out of solution and precipitate out, and in doing so, create some of the awesome hot springs. As you can tell, she's just having way more fun than she probably ought to.